Very good morning friends. Again in this video we are going to continue our journey of solving the questions of integrations from the CBSE and CIIT class 12 books, and the exercise number 7.5. This chapter deals with the partial fractions, integration of the partial fractions. We have solved the first 3 questions, and then from this question here I think it's number 4. So without wasting your important time, let's go back to the solving this question. This question is question number 4, I think. Yes, question number 4. It goes like, find the integral of this I equals x over, and then we have x minus 1, x minus 2, x minus 3, x minus 1, x minus 2, x minus 3 dx. Now if you just look at this only as a fraction with the terms like x over x minus 1, x minus 2, x minus 3. Numerator is a polynomial of degree 1 and denominator is a polynomial of degree 3. If you multiply these 3 linear terms, you'll get a polynomial of degree 3. It means this is a proper rational fraction, and since all these denominators, all these terms in the denominators, all the factors of the denominator are linear, then they should be expressed like this: a over x minus 1 plus b over x minus 2 plus c over x minus 3. Now take LCM. So the LCM of these 3 will be x minus 1, x minus 2, x minus 3, then a, x minus 2. In the case of a, it will be x minus 2, x minus 3, plus b, x minus 1, x minus 3, plus c, that is x minus 1, x minus 2, x minus 1, x minus 2, and here you have x over the very same thing. I'm not writing, you have to write. I'm not writing, I can skip because I'm giving you teacher, I'm not writing in the examination. So here, now these 2 terms have the same denominator. So in the next line, without going to this, I simply remove the denominator because we are just comparing their numerators. So this becomes like this. So you just one by one, because 3 factors are different. If you write x equals 1, then in case this, wherever you have x minus 1, they will cancel, they will become 0. So this becomes 1 equal to, this becomes 0, this becomes 0, then this is the value, that is minus 1. 1 minus 2 is minus 1, 1 minus 3 is minus 2. Both terms are negative, minus 1, minus 2. If you multiply, you get 2. So 2a, it means you got a as half. Same way, if you put x as b, 2, then this vanishes, and then you get 2 is 2 minus 1 is 1, and the 2 minus 3 is minus 1, so it is minus b. It means b is minus 2. X is 3 if you put, then this vanishes, x minus 3, this also vanishes, and this remains. 3 minus 1 is 2 and 3 minus 2 is 1. So 3 equals c. It means our this fraction becomes, a becomes half, b becomes minus 2, so I make this plus as minus and the 2 there, and c becomes 3, so this 3. Now this has been broken down into 3 fractions. Now instead of integrating this, I want to integrate this part. Right now is not required. Now I can integrate this one directly. So this dx will be this dx, this dx, this dx. This will become half log mod x minus 1 minus 2 log mod x minus 2 plus 3 log mod x minus 3 plus c. This is your answer. Now I go for question number 5. Question number 5. find the integral of I as 2x over x square plus 3x plus 2 dx. So find this is quadratic polynomial. Denominator is quadratic polynomial, numerator is a linear polynomial, and idea wise the degree of the polynomial in the denominator should be more than the degree of polynomial in the numerator. That's fine, but this looks like a quadratic equation. The answer is that can I factorize it into the linear term? Yeah. So just see. So x squared plus 3x plus 2. If you factorize, you get x squared plus 2x plus x plus 2, and this gives you x plus 2 plus 1 x plus 2, and this is x plus 2 x plus 1. So this is 2x over x plus 1 x plus 2. Now I can write this one, so let me write this part here. 2x over x plus 1, these two are linear, so x plus 2, they can be written as a over x plus 1 plus b over x plus 2. So this is how, because both these are the linear factors, that's why I have to write a over x plus 1 and b over x plus 1. How? So in the previous video we have discussed the various forms, or just before your this exercise in the textbook you must be given in the table, it's all written there. Then I take the LCM here directly, so this becomes x plus 1 and x plus 2, this becomes a times x plus 2 plus b times x plus 1, and this is 2x over x plus 1 x plus 2. Now if I compare the numerator, then I get 2x as a times x plus 2 plus b times x plus 1. Now try to get rid of these factors one by one. First you assume x is minus 1. So when x is minus 1, this part vanishes. So minus 2. 2 into minus 1 is minus 2. And this is minus 1 plus 2 is 1. So minus 2 is a. Then x is minus 2. This becomes minus 4. This vanishes, and the minus 2 plus 1 is minus b. So b becomes 4, a becomes minus 2. So this is b. Now our fraction becomes, this becomes a, that is minus 2 over x plus 1, and b is 4 over x plus 2 dx. Now I have to find the integration of this expression, but before that I have to break this down into two integrals. So this first one is minus 2 integration of 1 over x plus 1 dx, plus this is 4 outside integration of 1 over x plus 2 dx. This gives you minus 2 log mod x plus 1, because integrations of the form 1 over x gives you log mod x, and here this is 4 log mod x plus 2 plus c. This is your answer. So question number 5. Now I go for question number 6. This is question number 6. I equals integral of 1 minus x square over x and 1 minus 2x, x and 1 minus 2x dx. Now this is little different, because the degree of polynomial in the numerator is 2, and the degree of polynomial in the denominator is also 2. Now both the numerators and denominators have the same degree of polynomial. It means this can be treated as the improper fractions, and this needs to be converted into a complete fraction, a complete polynomial, and then a rational fraction. Now how? So first I do that just to go by division method. So just in these cases, whenever you have the degree of polynomial of the numerator is more than or equal to the degree of polynomial in the denominator, you have to use the divide method just to express the denominator, or you have to express the numerator into the terms of the denominator. How? It is just like if you might have studied in the arithmetic, whenever you have the cases like 18/5, this is improper fraction, so you just go by division method, divide 18 by 5, 5 3s are 15, and the remainder is 3, and you write this as 3, this is the whole part, 3, and this is the remainder there, 3 by 5. This later becomes 3 plus 3 by 5. We have to adopt the same method here also. So what I do that, first let me write this numerator, which is 1 minus x square. Now I need to divide, but I expand this before division. So x times 1 becomes x, and this is minus 2x, that is minus 2x square. Now I have to divide 1 minus x square by x minus 2x square. So I write here half, because if you have half into 2x square, then only you can get this x square. So half x into x, if you multiply, then you'll get half x square, and this one's integration increases. So first I don't think I need to have, I just take only half. So half into x is half x, minus half into 2x square is x square. Now change the sign, minus plus, these two cancel, and you have 1 minus half x. It means the whole polynomial, this one, can be written as first this one half plus this one 1 minus half x over this one, and instead of writing this one, I would like to write this in this form. So this is x 1 minus 2x. So now what I do that, I write this as half plus, at the place of this you can write 2 minus x, because if you simplify, this becomes 2 minus x over 2 over x 1 minus 2x, and this whole dx. This all till now will be treated as one expression. Now I can break this down as the integral of this plus integral of this. There is half integration of 1 dx plus this 2, I'll again take it outside, this into 2 minus x over x 1 minus 2x dx. Now you can see that I have to again express this in the form of, because this is right now proper rational fractions, because degree of polynomial in 2 minus x is less than the degree of polynomial in this one, because it is linear and this is quadratic. So first let me remove this part, and I write this 2 minus x over x 1 minus 2x as a over x plus b over 1 minus 2x. Clear? So now I take the LCM as usual. This is x and this is 1 minus 2x. So this becomes a times 1 minus 2x plus bx, and this becomes 2 minus x over x 1 minus 2x. Now since their denominators are same, I just compare their numerators, which goes like 2 minus x is a times 1 minus 2x plus bx, and then you replace 1 by 1. First you take x as 0. So when you take x as 0, this part b into 0, this part vanishes, and here you have 2 minus 0, that is 2, is a times 1 minus 0, that is 1. So a values you got directly that as 2. And now if you put the 2x as 1 or x as half, so x as half, this part, or I'm just taking 2x as 1 or x as half. So 2 minus half, this becomes 2 minus half, this part vanishes now, and here you have half b. Now 2 2s are 4 minus 1, this becomes 3 over 2 and 1 over 2b. So b becomes just 3. Okay, so now this question can be written as half integration of 1 dx plus half. I break this down directly because here I have a fraction, this bracket, because here this one is giving me two integrals, this and this. So first I go for A, so 2 integration of 1 over x dx, then b gives you 3, so plus 3 integration of 1 over 1 minus 2x dx, and then you keep everything inside the box. So now I integrate here, half integration of 1 dx is x, plus half and 2 cancel, and integration of 1 over x dx is log mod x, plus this becomes 3 by 2. Now this is integration of 1 over something, 1 over x, integration of 1 over x is log mod x, and integration of 1 over something is log mod something divided by differentiation of that something. So this term will become log mod 1 minus 2x, and then you divide this by differentiation of this 1 minus 2x, which is minus 2. So this minus 2 and further minus 2 will become minus 4. So I write here 4 and change the sign as plus as minus, and this is your final answer. Now I go for question number 7. Question number 7. I as integration of x over x square plus 1 and x minus 1 dx. So now this is a linear polynomial, this is quadratic, and this is linear. So overall this denominator will become cubic. Fine. Now how to break this down, because this is linear and this is quadratic. Now pay attention. This can be written as x over x square plus 1 x minus 1 equal to. For linear part you just write a over x minus 1, no problem, you can always write like that. But for this quadratic part you have to write this as bx plus c over x square plus 1. Now as usual take the LCM, x minus 1 and x square plus 1. So this becomes a times x square plus 1 plus, now you multiply this directly, so this gives you bx square plus cx minus bx minus c, and this part as it is, x over x square plus 1 x minus 1. Now compare the numerators only, so write x equal to, at the same time make a proper grouping of the right coefficients. So x like terms like ax square and bx square together, write a plus b x square. Then here you have cx minus dx plus c minus b times x, and then a1 and then minus c, and this becomes plus a minus c, and this is x. So in this case we are not going to put the values of x arbitrarily to cancel some of the coefficients and find some of them. Here what we do, will compare the coefficients. So on the left hand side you see there is only x, this is not there, so you can assume this x to be like a whole expression like 0x square plus x plus 0. It means the coefficient of x square as 0. So what do you get? You get a plus b as 0, c minus b as 1, and a minus c is also 0. So a equal to minus b. So at the place of this minus b, if you write a, this becomes c plus a is 1, and then you have a minus c is 0, means a is c. If a is c and a plus c is 1 means 2a is half, so a equal to half, c equal to half, and a is minus b, so b is also minus half. So this whole expression becomes I equals, first a is half, so keep half outside, 1 over x minus 1 dx, plus for second part b is also half, c is also half, one is negative, one is positive, So you can write this as, I want to write c first because the order will help me. C minus half x over x square plus 1 dx. Now right now this is getting quite messier, so I think this part you have already understood. So let me get rid of this part. So this part I remove. So now let me elaborate this point. So there you get half integration of 1 over x minus 1 dx plus half outside 1 minus x over x square plus 1 dx. Now after solving so many questions, you might have developed some intuition method, and that helps you. So here I see that if I try this, break this down as this, so one part is x square plus 1, I'm directly getting as 1 over a tan inverse x upon a, and if I write x over x square plus 1, then using the proper method of substitution, I can find that answer as well. So first let me write the standard form in, like 1 by 2 integration of 1 over x minus 1 dx plus 1 over 2 integration of 1 over x square plus 1 dx minus 1 by 2 is x dx over x square plus 1. So now if I integrate this one directly, I will find the answer as I as half log mod x minus 1, half log mod x minus 1 plus this is 1 by 2, this is tan inverse x, that is tan inverse x, and this is, if you take this x square plus 2, for just a little briefing, x square plus 1 as t, you get 2x dx as dt, means x dx as half dt, and this becomes half dt over t, that is again log mod t, but half and half this together will become minus 1 over 4, and this one become log mod x square plus 1 plus c, and this is the answer for this particular question. Now I go for question number 8. Question number 8, integral I, you have to find this as x over x minus 1 whole square, x over x minus 1 whole square x plus 2 dx. So now in this form you need to write this whole thing as, now I am just going a little faster. So this is x over x minus 1 whole square x plus 2, this is x square, and this is a over x minus 1. For this we write first once, then we write for second time also, for b over x minus 1 whole square plus this one for c over x plus 2. Now take the LCM, so the LCM will be just x minus 1 whole square x plus 2, and for a case this is x minus 1 times x minus 1 times x plus 2, for b it is just x plus 2 times, for c it is x minus 1 whole square times, and this is x over x minus 1 whole square x plus 2. So I write x equal to, at the same times I expand these terms, so it becomes a x square plus x minus 2 plus b x plus 2 and plus c, this is x square minus 2x plus 1. Now make the proper arrangement of the coefficients. So a plus c gives you this one, a plus c x square. Then we have x here, so ax plus bx and minus 2c all have x, minus 2a plus here minus 2a plus 2b plus c, and this is x. So now I compare the coefficient, so x square is not there, it means a plus c is 0. So a plus c is 0, a plus b minus 2c is 1 because this is x coefficient is 1 here. So a plus b minus 2c is 1, and this also is 0. That is minus 2a plus 2b plus c is 0. Now a plus c is 0, it means a is minus c. Now put this value of minus c. So now here is the second equation. So minus 2c is 2a. So this becomes a plus b plus 2a is 1. So you get 2a plus 2b, sorry, 3a plus b as 1. 3a plus b as 1 because a plus 2a is 3a. Okay, now put the same thing here at the place of the c, write minus a. So this will become minus 3a, and this a becomes minus c, or c becomes minus a. So at the place of this plus c, I have written minus a. So minus 2a minus a becomes minus 3a. 2b remains as it is, 2b equals 0. Now I solve these two. So a cancel, you get 3b as 1. It means b as 1 by 3. Now put the value of b in any of these equations, either this or either that, and then you will find the value of a. So b, you see b you are getting as 1 minus 3a, or 3a you are getting as b 1 minus b. So first I write into this expression only here, not cross, into this one I am going to write the value. So 3a plus 1 by 3 is 1. So 3a is 1 minus 1 by 3, that is minus 2 by 3. So a is minus 2 by 9. So a is minus 2 by 9. B is 1 by 3. And c is just negative of a, so c is also 2 by 9. So three values I have already found. So now first let me write here, then I'll get rid of all this messed up stuff. So a is minus 2 by 9. So remove this a, make this as minus 2 by 9. B as 1 by 3. Get rid of this, write 1 by 3. C as 2 over 9. So get rid of this and write 2 over 9. So now I remove these things. Okay, now instead of integrating this, we'll be integrating this. So our integration I now becomes I minus 2 by 9 integration of 1 over x minus 1 dx plus 1 by 3 integration of 1 over x minus 1 whole square dx plus 2 over 9 integration of 1 over x plus 2 dx. Now on integration this becomes 2 by 9 log mod x minus 1 plus, what is the integration of 1 over x square? So integration of 1 over x square is just minus 1 over x. How? So integration of x to the power minus 2. 1 over x square can be written as x to the power minus 2, and this gives you x to the power minus 2 plus 1 over minus 2 plus 1, that is x to the power minus 1 over minus 1. Now it is minus 1 over x. Same with integration of x minus 1 whole square will give you minus 1 over this. So this plus 1 by 3 will become minus 1 by 3, 1 over x minus 1 plus this is 2 by 9 log mod x plus 2 plus c. This is the final answer. Now the question number, so now here the question is I as 3x plus 5 x square minus x cube minus x square minus x plus 1. So now I want to factorize this. So we can write this as 3x plus 5 over, first you take x square common from first two terms, that is x square x minus 1 minus 1 x minus 1 dx. So this gives you 3x plus 5 over x square minus 1 and x minus 1. Now x minus 1 can be further broken down as x minus 1 x plus 1. So I write this one as x minus 1 and then I write this one as x plus 1. Since we have 2x minus 1, I need to remove 1 and put the power of 2 there, and that is x plus 1. So this is the whole rough work part. You don't have to write everything in much detail. Now this is a proper rational fractions because denominator is a linear polynomial and the numerator is a cubical polynomial. So we write this thing 3x plus 5 over x minus 1 whole square x plus 1 as a over x minus 1 plus b over x minus 1 whole square plus c over x plus 1. Take LCM. This is x minus 1 whole square and x plus 1. So x minus 1, so this is a times x minus 1 x plus 1 plus b times x plus 1 just, and plus c times it is x minus 1 whole square. So now this becomes a times x square minus 1. This is bx plus c, and this becomes plus c times x square minus 2x plus 1. And I write only the numerator part because the denominator is already same, so I can save some space and time also. Then I try to regroup the like terms together, so that is a plus c x square. Then we have b, and this is minus 2x, so b minus 2c x. Then we have some constant, that is minus a here, plus c here, and plus 1 more c is there, and this is 3x plus 5. Now compare the coefficient. X square coefficient on the right hand side is a plus 3, and on the left hand side there is no x square. It means the a plus c is 0. So a plus c is 0. b minus 2c, b minus 2c is 3, and then this one is minus a plus 2c equals 5. So now if I solve, then I get a equal to minus c. So if a here is minus c, then minus a is c. So this becomes 3c is 5, c is 5 over 3, and a is minus 5 over 3. Now b minus 2c is 3. How to find the value of b? b minus 2c, where c we have already found as 5 over 3. So b minus 2 times 5 over 3 is 3. So b is 3 plus 10 over 3, that is b is 19 by 3. Now you see we are getting a as minus 5 by 3. So this is minus 5 by 3 integration 1 over x minus 1 dx plus b is 19 by 3. 19 by 3 integration 1 over x minus 1 whole square dx plus c is 5 by 3. So 5 by 3 integration over x plus 1 dx. Okay, so when I start solving these questions many times or almost every time, I do not check the answer. So even I may not be sure whether I do it correctly or not, but I do it with utmost sincerity, and my calculations are not that bad and good. They are definitely. So I expect that they will be 100% correct. But if not, then if there are slightest any changes in the coefficients, maybe when I am solving so many questions in one go, I may make silly mistakes. This is the human fault, and humans are prone to make some errors. In that condition, I tender my forgiveness, and then at the same time, you are wise enough to make certain silly changes if required. I expect that you may not find that quite often, but if it happens, then for sake of convenience I'm saying. So here I remove this part of screen. I is, now I integrate, this is minus 5 by 3. Form is already written 1 over x minus 1. This is log mod x minus 1 plus 19 by 3. In division of 1 over x minus 1 whole square, or 1 over x square is minus 1 by x. So I write 1 by x here, I make this plus as minus. And then in division of 1 over x plus 1 is plus 5 by 3 log mod x plus 1 plus c. Now these 5 by 3, this is 5 by 3 positive, this is minus 5 by 3. If you want to regroup them together, then you can take 5 by 3 common, and then you get log m minus log n is nothing but log m minus n. So it is x plus 1 over x minus 1, and this part minus 19 by 3x will be very much there, and this is your answer.